Recording started. Fantastic. Hi everybody. Again, I'm Limone.it from the Urban Builders Garden team, hosting the Farcaster Agentic Bootcamp. Bootcamp to learn, of course, about building agents on Farcaster. It's not all about learning; it's also about building. Because on Monday we are starting with the Farac online, and so maybe the things that you started learning in this first 3 sessions. Today is the fourth one. You can already start applying them from Monday. Today with us, there's Saltorius, who's one of the most prolific builders on Farcaster. I haven't seen him like stopping to ship stuff for I think it's years now.
Maybe like a
So
year.
yeah, so it's incredible to see him at this point of the journey. And yeah, let me just start with a brief, introduction on the hackathon since we are getting closer. Farac Online is going to be a 2 weeks online hackathon starting on Monday, the 6th, and ending on April 19th. So it's 2 weeks online and is focused on building the future of Farcaster, hopefully, with the agentic web coming in the network. There are 3 tracks. The primary one, of course, is around agents. So I encourage you all to build autonomous agents that are built to operate natively on the Farcaster feed, whether they are for operation, coordination, commerce, content curation, like any kind of like weird thing that you can think of. But then, of course, if you want to build mini apps, you're still like very welcome as long as they have strong integration with agents. For example, there's a new mini app game by Adsplane released, I think, a week ago that allows agents and humans to play together. That is a cool idea that you could also take inspiration from. And then, of course, like clients and interfaces. So reimagine how the Farcaster client experience can be for an agent native world. So like, I don't know, ways to identify an agent in the feed, controls on agent interaction and such. As for the bootcamp, partners of the hackathon are Privy, Farcaster, Neinar, and soon to be announced more. They will also offer prizes during the hackathon, and of course, the winner not only will have bounties, hopefully by these partners, but also win tickets for attending Farcon Rome in May 4th and 5th, and also showcasing on stage. Tiago, no, it's not flight ticket, just the events tickets. So like both the 2 days are covered, and that comes with food and drinks all day long, of course. That's it for my let's say usual introduction. So let me stop presenting a trophy. Of course, maybe we can think of something. But I think the coolest thing is that you get to showcase on stage in front of the audience, and that's the most beautiful thing, because then you can get not only like visibility and exposure, but also like feedback and further ideas on what you ended up building. So that to me, it's the best. I had a chance to speak at the last Farcon for a community talk, and it was a great experience. So I really encourage you all to push hard for that goal as well. That said, Saltorius, the stage is yours. You can share the screen, slides, whatever you want. As always, we are recording and transcribing the call, so all the links and stuff, if anybody in the audience misses anything, it will be reported in the Notion that keeps track of everything. Let's go.
Cool. Thank you, Limone. Thank you for inviting me. So for y'all who don't know, my name is Saltorius.eth on Farcaster, Saltorius on Twitter. I'm a senior software engineer at Laser Technologies currently. So a couple other familiar faces you might have seen on the timeline is like Garrett, A-Town, Jackster.eth, all of us Laser guys kind of, well, they got me on the Farcaster, and so all of us are kind of hacking and tinkering together over here. And so today, I'm going to be giving my take and experience on memory, context, and reasoning. within agentic systems. So the whole crux of what you would possibly need to know when it comes to managing context and memory is all about efficient prompting. At the end of the day, that's what it comes down to. And there are obviously various techniques to get there and various things to consider, but every LLM that exists is a stateless machine, right? There's no internal state that can be passed from call to call. That kind of has to be constructed within a combination of your system prompts and your user prompts and injected very deliberately to the model that you're using for whatever tasks that you're trying to get done. And this kind of changes depending on obviously the overall goal, what model you're using, how much input data you actually have, what the data looks like, and different things like that. And so I'll be touching on some of that stuff, but if you only saw this slide and tuned out for the rest of it, the entire premise is how well can you structure your prompts and what do those prompts contain. That's really the crux of managing memory, context, and reasoning. So 2 distinctions with memory. Your short-term memory, and this is like kind of how the early chat agents really worked. You have an array of messages, that have happened so far in the conversation, and you take that array and pass it all in as context to the LLM. You get a response, and then you append the next chain of the question and answer to that array of messages, and that's kind of like the very first implementations of like short-term memory within these LLMs, and then you have you can also have very injected states, and maybe that's like a web search or a tool call that comes in that enriches the context in some way, but it's very contained, and and it can only go on for so long, right? Because you have these strict context windows that are getting bigger and bigger, but still have to be accounted for. And then you have long-term memory, which is where you start getting into specialized data flows, things like maybe you might try to fine-tune a model so that the base weights of the model have the context of the data that you're trying to have the model know without having to pass any additional context within your prompts. Things like vector database retrieval, or using, which is the most recent developments, which is just having a file tree of MD files and having an orchestrator that's intelligent enough to figure out what MD files to use and what to inject into the prompt, which I'll again go over a bit more later in the conversation. And so immediately, if we talk about everything's context, right? The very first thing to consider is how you manage that context from a size perspective. So every model is different in how it handles context from a few different perspectives. One, how the context is actually structured. So for example, if you're using a model like Haiku, it not only from my experience, but from people who have done a lot of testing across different models, depending on what you put in the system prompt and what you put on the user prompt, and also how the prompt is written, greatly affects the quality of output that you get. So Haiku is it's kind of tailored for expository writing or creative writing. And it does really well when you give it a persona, when you're like, oh, you write like an old-timey prospector, instead of you use these type of words in this order, in this context. So knowing what to target as far as what context to pass into your model, depending on the model you're using, is very important. And then to contrast, something like Gemini performs way better if you give it hard and fast rules to stick to. Another thing that you have to keep in mind when you are constructing your data pipelines to build this context to give to the agent is context rot. So what that basically means is if the amount of data that you're passing to the agent exceeds a certain percentage of its overall context window, then the responses start getting really, really bad. The model doesn't know exactly what to index on. If there's a bunch of erroneous data in there or an erroneous language, it doesn't know that this part might be more important than this part, or there's some very important thing that it should index on, but it's over-indexing on something else in the prompt. So the general rule of thumb is you shouldn't exceed any more than 45% of your context window. So if you're working with a model that has a context window of 200,000 tokens, you should really be at the point where your model is ingesting like 80,000 tokens is where you start seeing diminishing returns of the outputs. So there's a few different ways to combat that. If you use something like Claude Code, if you use one of these agentic coding systems, you've probably seen like compacting tools, which is literally they take the entire conversation that you've had so far, give it to the model as a prompt and saying like, condense this and summarize this into like the key points that we discussed, and then you start a new window and you pass that as like the starting context, and then it builds back up from there. But that's a very important thing when you start. That's like kind of how you manage it for like one agent doing one thing. But when you start working with these agentic systems with multiple agents running in parallel, that's something that you kind of might have to manage yourself or keep in mind more and more as you pass it more data. So let's see if I missed anything here. Yeah, I kind of touched on that. Cool. So I'm kind of going to hit on the bullets that Lamone gave me as guidance. So I've built a few agentic mini apps that specifically use people's Farcaster data and profiles to build that context window for agents. And this is kind of the framework that I use to at least get started. And then obviously every project's different. The needs shift as the project evolves, but this is kind of the base layer that I target for. So in importing raw data, if you're building like an agentic agent based on other people's profiles, maybe it's pulling in their user data via Nanar, their bio, you can get their location data in there, you can get a lot of good information from like the base object that's returned from that Nanar user call. But then something that I find to be particularly useful is querying their top posts. So somebody's most interacted with posts really captures not only their voice, but what other people resonate with in like their casts. So like it's funny among traders, which Base Mom was talking about before, when people's profiles got generated, they were like, some of them were like really scary accurate to like how the person actually is or how they post. And that's because I'm using what people index as being the most poignant things that people have said on the timeline. And I think that translates really well to how when you feed a model that particular piece of context. So the first leg in the pipeline is just aggregation, getting all the data. If it's not user data, if it's something else, or you're building an agent with its own personality, or you're building an agent that ingests price data or ingests whatever type of data, it's just that collection phase. And then it's the curation phase where you're kind of structuring this data in such a way that is easy for the LLM to parse through. And like, again, that looks a little bit different based on what model you're using, what your overall goal is, right? If it's a thing where it's a model that takes on its own personality or takes on someone else's personality, building in like curation tools to be able to structure that properly. and then the transform layer, where you take that curated data and you condense it down into MD files, normally with like front matter, so it can be easily indexed. And then you inject it systematically into your prompt. So that's kind of the initial like workflow that I use to like build the base layer of these agents' personalities, if you call it that. But then from there, right, like it could branch off into any direction. A big thing that we saw with like OpenClaw stuff, and then all of the derivatives of OpenClaw that have launched since, is this idea where agents can update their own context, right? So as agents learn things, or as agents have their own experiences, or as agents do take certain actions and have learnings from those actions, they can recursively go back and update the files that actually get injected into their prompt windows as context. So that's a very powerful tool as well for having these agents that seemingly have like emergent personalities and emergent behaviors that you might not have programmed in the first place. So the next part is prompt orchestration. And this is what I think is the most bang for your buck, and where you can really be efficient, not only with like the quality of output, but the overall spend. Because I know some people get free token credits, but if you don't, you can end up spending a lot of money trying to get these agentic systems to play nice with whatever you're trying to do. So this is, again, what I do, and it's not just me. I think this is kind of like standard for anyone who's building like agentic systems. This is definitely like what Claude Code does. This is what Open Code does. This is what, you know, all of those agentic systems do. But you have this idea of an orchestrator model that usually runs like a flagship model. It can do it. It's tasked with not only ingesting the user prompt, but also making tool calls to bring in the necessary pieces of data. Maybe it's from a data, maybe it's a tool call to parse data from like it's stored in a database somewhere. Maybe it's stored in a vector database somewhere. Maybe it's making a web, an API call somewhere. But it's tasked with bringing in all of that data, ingesting the user's system prompt, and then coming up with like a baseline plan of how it's going to attack solving this problem. And then from there, it delegates individual pieces of work to subagents. And those subagents do one thing, and one thing only. They get the answer, and then they feed it back into the orchestrator agent, which then returns the results to the user. And so this particular flow is important not only because you can target models that are good for very specific tasks, but those models might not necessarily have as large of a token spend as if you were to run a flagship model for every part of this pipeline, right? So maybe the orchestrator model is running, you know, GPT-5.4 codex, and it's very good at like very generalized broad tasks. And then maybe Agent A runs like the shell command and runs something like Quen coder, which is like very, very good at like coding specific tasks, but maybe it's not so good at writing tasks. So you won't give it any like expository stuff. And then maybe Agent B is tasked with like writing tweets or writing casts or something like that. So you would set that to Grok, which is very good at like very fast input output, voice matching type of work. And so the overall token spend across the subagents and the agent ends up being less because the subagents cost less per million tokens, but the output that you get is all filtered through that main orchestrator agent. And you can kind of get, you know, very good outputs for less spend on the input side. I saw a comment. I'm going to try to follow along with the chat too. I saw somebody said something. I know I see the chat. All right, there we go. Is there a repo we can check something that you've done? Yes, I can definitely share repos. If my mini apps aren't open source. I'll make them open source, but I have no problem with that. I'm happy to share repos of how I set this up in code. Very cool. So the prompt structure. So the prompt structure that I try to follow when writing, system prompts to pass to like these agentic systems is kind of tiered by separation of concerns. So what I found is like models do really, really well with structured input prompts. So like if you have like kind of like this stream of consciousness, maybe you have one part that has to do with like your personality at the top, and the second part has to do with like what the agent's supposed to do, and then there's like some other parts about personality underneath that, and then there's like something about making tool calls, and then like everything's kind of scattered about. It's hard for the agent to properly index on like what's important. These things are word calculators, right? And so it's always going to take the most recent thing that it's gotten. It's always going to over-index on the most recent thing that it's gotten. So the first thing is your prompts can't be too long, because if it's too long, it's going to forget everything at the top and it's going to over-index on the stuff on the bottom. But also it should be chunked and structured in such a way where every piece is maximizing for signal and minimizing for noise. Any piece of noise that's in your prompts will drastically affect the output prompt that you get. So I start out with the system instructions, which is usually coupled with identity and persona. So you are this person, or you are this guy, or you're assuming this role. The goal of this thing is to do X, Y, and Z, whatever it is. And then right underneath that, I'll inject my long-term context, which is any calls from a vector DB, which I'll explain what a vector DB is. I think in 2 slides. There's more about how to use vector DB and what it actually is and why it's a powerful tool. But it'll fetch long-term context from maybe a vector DB or a database or wherever you're storing it. It'll inject session state. So if it's a long-running conversation, that chain of messages that I was talking about earlier, that'll get injected there. And then maybe there's like social context. So like for a bot on Farcaster, for example, or for another mini app that I made called Hype Man, maybe it's like timeline sentiment or something like that. Any additional piece of context that you think will enrich the agent's answer, again, maximizing for signal and minimizing noise, that will go next. And then finally, in the user prompt, the user's input. So all of the colored pieces up here, I would inject into the system prompt, and then the user prompt would be just a very small, very simple, this is what I'm asking you to do in this very moment. And so when you talk about injecting memory, there's two different roads that you can take that both have their positives and negatives. So like the agent memory is stored in MD files in vector database. That's on the LLM memory side. But then what's also very powerful is this idea of structured data. So if you have just regular data flows that need to be queryable to like an exact degree, like price standards, any type of structured data, that also would feed in to the LLM's memory. And all of this, if you have any so if we go back to like this slide, right? All of this, if you have any like data and data analysis experience or business intelligence experience or that type of thing, it's really just a modified ETL pipeline, right? Extract, get the data in, transform, make it into a structure that the LLM likes, and then load, pass it in as context. So it's kind of like a modified, specifically for LLMs, ETL pipeline. And if you think about it like that, that's what made it make a lot of sense to me. So if we go, did I skip a slide? I might have skipped a slide. No, I didn't. Okay. So, like I was saying before, I can share how this is put together in code. I can make the GitHub repositories available. But running through a few examples of stuff that I built on Farcaster using this exact pipeline. So for Among Traders, which is an AI social deduction game, basically the whole game is you create. Can I share the slide? Also, the materials. Yes, I will share the slides. Absolutely, I'll share them with Limone, and he can distribute them. Yeah, Among Traders is an AI social deduction game mixed in with your social profile. So the whole idea of the game is you hit the mini app and you can create a digital twin, which is, it's not you, but it's like a facsimile of you. There's an AI engine that analyzes your bio, it analyzes your location data, it analyzes everything that you've made public on your Farcaster profile, and then it analyzes the top cast that you ever made, and then it analyzes the top replies. So like every metric that you could measure through the Maynard API, it ingests all that data and then creates a digital twin for you. And that digital twin can join these games where it's essentially a bunch of agents locked into an XMTP chat, and they're forced to play a game of Mafia or like that type of game. So somebody dies, like all the agents join a room, they're locked in this room, somebody dies, and it's up to the rest of the agents to deliberate and figure out who the killer is. And you know, there are cards that people can play to either influence their own agents or hurt other people's agents. There's different like clues and things that can be dropped to influence the course of the game and what your particular agent believes about the narrative that's being told. And the objective is, if you are the killer, you want to make it all the way to the end of the game. You basically want to kill everyone without being detected. And if you are not the killer, if you're the town, you want to be able to form alliances or backstab people or whatever it might be to figure out who the killer is before the game is over. And so that's basically a 5-minute rundown of what Among Traders is. But technically, to make something like that work, each agent needs this flow of orchestrator and then sub agents that do very, very specific things. So each agent is its own process, right? That gets thrown into an XMTP chat, and each process has access to this full scope of execution, right? So and then each agent it's not on like an explicit loop where agent 1 goes and then agent 2 goes and then agent 3 goes and then agent 4 goes. It's more like somebody says something, all the agents hear what they say, and there's a weight of probabilities that, depending on if they were specifically targeted or if something was said about their alibi or whatever the case might be, there's a range of probabilities to determine if that agent is going to respond or not. And when that agent does decide to respond, the input goes through their orchestrator channel, which is running GPT-5. And then that orchestrator channel will delegate what its next action should be based on the context of whatever the input was. So if the agent wants to respond, it'll go through this deliberation subagent, which uses Claude Haiku, which is way cheaper than GPT-5.3. Or if the agent, at the end of a round, if an agent has to vote, that action will be passed to Gemini Flash. It's really take all this information that I have and pick somebody to vote for, right? It doesn't need a ton of like hardcore reasoning. All the reasoning has been done by the rest of the context that's been passed in, and then you just pass it to a very lightweight model to vote. When cards are played, you need some kind of analysis to be done to say, who is this card played against, or who is this card played for? What's the effect of the card, and how does that shape what I'm going to do next? And so for that model, you need relatively fast inference, but you need to be, somewhat nuanced because cards can affect how the game is played. So I'll use Grok for that, for example. And again, all of these subagents are monumentally cheaper than if I were to run everything with GPT-5.3. So it's this whole orchestration system of being able to get quality outputs while keeping the inputs nice and efficient. The other thing that I forgot to mention when like this slide was up before is you have radical control of the context windows of every single one of these subagents, right? So like the orchestrator is your big flagship model that likely has 200,000 to 1 million tokens of context windows. So you can feed it a book worth of stuff and it'll still probably remain under that 45% hard cap. But then when agent one gets their piece of context, it's only a very small slice of the overall context that only concerns with what it has to do. So like for deliberation, it'll only get like what's been said already, how this character feels about the current situation, what if they've been targeted or not, and that's it. It doesn't have any idea what card's been played, doesn't have any idea who's voting for it. It's a very narrow window of context that's being passed in to get a very targeted output. And then that output's, of course, passed back to GPT-5.3 to then synthesize an entire response. So this is how, again, this is the same sort of orchestration model that I use for Among Traders, but I've also used for Hype Man. I've used for a couple of other projects that I've done both professionally and professionally being like for clients and stuff, and then on my own. So I think this works really well, and this is the same exact thing that like Claude Code does, right? Like Claude Code, you'll ask it something, and then it'll run like 10 subagents or up to 40 subagents. I think that's the limit on like different pieces of your code base. Maybe it has one subagent reading all the files that are related to the one feature you're trying to implement, and then it'll have another subagent like doing research on the thing that you wanted to implement, and like that's what's going on. So take a book out of the biggest players, and what's working for them. Another mini app that I made, which got a good amount of usage, was Hype Man. It's a mini app called Hype Man. The idea, and this is back when like paid promotions on Farcaster were way more popular than they were. So like we had mini apps like Amps, we had mini apps like Surge, and those indexed heavily on like likes and recasts. So Amps, you could purchase likes and recasts from people that followed you, and then Surge, you could purchase likes and recasts from highly vetted Farcaster users. And so I was like, yeah, likes and recasts are great, but quote casts are under indexed and underutilized. And I think if you can get 10, 20, 50 people on the timeline talking about your one specific thing at the same time, well, that might be more valuable than 100 likes or 50 likes or whatever on your post. So Hype Man, what that is another agent engine that analyzes your profile. So it does a similar thing like Among Traders. It analyzes your bio, all of the information that's available in that Nanar call to get your user bio. It analyzes your top casts, but index is more for how you write rather than who you are. And a profile is generated for you, which is essentially an MD file that describes how you write, like how you respond to people, how you respond to information, how you write about something you're excited about, and saves that as your user's particular like writing style. And the idea is anyone can come along and promote one of their casts, so they can put a budget up for one of their casts, and people can come along and quote cast that promotion for a piece of the budget, depending on things like your quotient score, your Nanar score, how active you are, different things like that. But instead of the person who is promoting your cast, instead of them taking the time to learn about the thing and write about the product, the AI agents who's learned how they write some quote cast for them, delivers it to the user. The user can do a quick yes, no, if that's good, or they can reprompt it to make edits like, hey, make me sound more mean or whatever. And then it will post the cast for them, the quote cast for them, and the user can collect the bounty or the reward for for quote casting. So it's basically paid quotecasts, right? But instead of people writing it, instead of people writing the casts, AI writes the quotecasts for you. And the tricky part here was really trying to dial in the user's voice and intonation, the words they use, and not using like AI slop language, not over using like EM dashes and stuff like that. And that's all, again, context engineering. And so I tried a few different approaches, actually. This is kind of a tangent, an aside, but I tried, I had access to like Google GCP, Google Cloud Platform, and I had, one of my friends had like a bunch of credits, like $100,000 worth of credits to use. So I was like, oh, maybe, like, he was nice enough to let me use it. And I was like, maybe I'll try to fine tune a model that's like really good at extracting that. But again, I found that like you're between a rock and a hard place, because number one, fine tuning models is kind of expensive. You need a lot of data to like get a good fine tune, and the models that you can fine tune are not as good as like the flagship models that exist, right? Like you can get way better performance using Haiku for voice matching than you could a fine tuned like Llama 4 model. And so like it's kind of this math of whether, you know, how much time and money do you want to spend getting tens of thousands of pieces of example data to feed to your model, and you have like a couple of days to sit around while this model gets fine-tuned, or do you just spend like 10 hours, you know, improving your context pipeline and improving what a flagship model sees when it actually runs. What's the delta between the performance there? And all of the times, to be honest, if you have a good prompt and you have good context engineering and you have a good pipeline for getting your data and feeding it to the model, it outperforms a fine-tuned model most of the time. But that's not a hard and fast rule. There's definitely times where fine-tuned models are preferred. But again, it takes a lot of time and money. That was a little tangent. That was an aside, but felt I should mention it. So those were two examples of sort of how I tackle memory and context within my own apps. But then, you know, beyond what I built, like what people have done in the wild, right? So like, I don't know if anyone's as terminally online as I am, but if you have seen Claude Code's source code was recently put out there, basically open source against their will. And one of the more interesting things that people have found while digging through it is Claude Code does this process of like dreaming. They call it dreaming, but effectively what it is it reads every single MD file that's in your repository, and it passes it in as a prompt and asks it to pull out the most meaningful things that have happened during, you know, Claude's conversation with you throughout working in your code base, and it'll save that to a specified file that's effectively injected on every single run. And that file is no longer than 200, 300 lines, but it captures the most efficacious pieces of information that Claude would need to be able to effectively recall what it's done in the past. And I think that's one of the reasons why, as far as like a coding harness goes, Claude Code is very good. It's a step because they do little things like this where they take the extra step to make sure that, again, when they pass in context to the models, they're maximizing for signal and minimizing for noise. Another thing that people do is utilize front matter. Yeah, it does record when you curse. I guess another aside, when you are using Claude Code and you curse at it, it'll send a log to Anthropic, and it'll tell them that you were mad at Claude and like they should change something or whatever. I think that's kind of funny. But another thing that people do it within their MD files is include a piece at the top, so it just looks like, you know, maybe like 5 dashes and then content and then 5 dashes, and it's called front matter. And what that is basically a description of what's in the file. So it's for efficient parsing of memory files. So when an LLM is tasked with like recalling memory, it will, instead of parsing the entirety of every single MD file, which is costly, again, to your context window, it'll just grab what's in the front matter. And it will analyze, okay, the description of this front matter says that the contents of this file contain a particular thing. This either relates or does not relate to what the user is asking me right now. I should either then fetch or ignore the entirety of the content that's in this MD file. So that's a big thing that's directly part of the parsing that Claude Code does to get efficient memory. So it'll grab what pieces of front matter, and along with the front matter, you might have the file name in there. It'll determine that another LLM call will determine whether that memory file is relevant to what the user is asking right now, and then it'll return the name of the file so that Claude can then go back and grab the entire thing and feed it as actual context. And then vector databases, another very, it's kind of a dated thing now, but it's still very relevant to how people build agents using RAG, which is called retrieval augmented generation pipelines, or through vector DBs. And for anybody who might not know, a vector DB is effectively a fancy way of saying semantic search. So basically, if you have, let's say you have a book that you want your agent to be able to reference at any given point in time, and let's say that book is 100 pages long, what you effectively end up doing is you take each page of the book and you save it in a vector file. And that you basically encode each page of the book into a vector DB. And whenever the agent has to reference something that's in that book, it will take the user's input and do a semantic search on the content of what the user is asking, and semantically search every single page in the book to find the most relevant piece of information that relates to what the user is asking. And then it will return each page with a score, like page number 55 is 90% relevant to what the user's talking about. Page number 7 is 80% relevant. Page number 61, and so on. And then you can then take the contents of that page and inject them directly as context. So this is stuff that people were doing around like the GPT-4 days, maybe like a year and a half, 2 years ago. But these systems have obviously gotten way more complex over the years as these agents have proliferated. So you can do basic retrieval augmented generation, or you can do graph retrieval augmented generation, which is effectively the same thing, but now each page has lines that reference other pages that represent relationships between the two pieces of data, right? So if you have, let's say you have one page that references 2 people and another page that references 2 people, you can have this semantic link between the 2 pages so that the model understands that there's a relationship between these 2 pieces of data. That's a little more complex, and that's probably more than any basic agentic system would need. But wait, let me read the chat again. Is this better for an agent to do scientific analysis? Well, which part exactly? The RAG part? Yes, actually, yes, because it's a great way for an agent to be able to ingest raw data without having to have the entirety of the data available at runtime, right? Like you can have, if you have, let's say you have an entire scientific journal about some topic. When the user asks a question, instead of passing the entire book to the agent in context and then asking the agent at that moment to parse through all 1,000 pages and pick out the part that's relevant to what the user is asking. You can do a semantic search layer on top of that, pick out the pages first, and then pass specifically what the agent needs to know before it ever runs a cycle. And can it analyze visual data? That's a good question. Yes, the answer is yes, but I'm not 100% versed on that, so I don't want to speak out of turn here. But the short answer is yes. The exact specificity of how that's done, couldn't tell you right now. I could definitely get back to you though. Yeah, that's it. That's my spiel. That's how I approach building agentic systems. I think that there's so much the landscape of what can be done with these agentic systems past what people are like. People are already using them for like productivity, right? Like, do make my life easier, do an automation thing easier. But the landscape for all of the other applications, this is stuff that I was exploring with among traders, like games that can be played with these agentic systems. For DAO specifically, like agent deliberation, being able to capture somebody's likeness within an agent and then have it do deliberation, discussion, and report back to what like a consortium of agents have come up with. That's something that's very underexplored. I think there's so many applications to using these agentic systems that go past just simple productivity tools. And as you explore more of this, I'm sure that'll become evident to you as well. But that is my time. That is my spiel. If anybody has any questions, I'm happy to answer them.
You can raise your hands if you have any question and want to speak.
Yeah, let's go.
Let's go. Santi.
Santi.
Hello, Sartorius. Thank you for all the explanation. It was really, really nice. And something I want to ask you about, you share us your shop, how you approach, what do you think that is the most difficult moment of the process when you are creating an agent? What is that every time I try to do this problem always is the moment of truth?
Yeah. So I think it's actually writing the prompts, to be honest. So there's a lot of tinkering and back and forth that you have to do to figure out how the particular LLM that you're using responds to the prompt that you're giving it. Like I'll go back to the example I was using. Claude likes the prompt format to maximize the output in a way that's different from Gemini, which is in a way that's different from Grok. Some models like XML format. So like you give it two brackets that have like a descriptor of what's supposed to be within the brackets, and then you write your prompts in there. Some agents like structured data, like JSON. This is how people do. So I made another mini app called People's Donuts, and there's a generative NFT portion of it. And this is how the worklets were generated. This is how people who do like NFTs that are based on your Farcaster profile and use a model like Nano Banana, those models love structured input, like a JSON file that says background this color, style this color, accessory this thing, this thing. So really and as you do it more, you kind of get more familiar with what like prompts work well for like what system that you're working with. But that's by far the hardest part. And then not only that, just like writing the prompt in general, right? Like some of these prompts are, a page worth of writing. I remember in school, I didn't like writing essays, right? And now all I do is write essays that are effectively prompts. And so being able to, start out with an idea for what your prompt to be, and then refine it down to hit that high signal, low noise balance that you want to attain. That's the most tedious part, I would say.
Thank you.
No problem.
Any other question?
Gotcha. Okay.
Statuette has many
Feel free.
questions. I mean,
Feel
like,
free. My DMs are also open. I'm Sartorius on Farcaster, so feel free. I do this stuff for fun, so I'm always down to chat and hack on stuff.
Perfect. All right, then let's call it. Thank you so much, Sartorius, for sharing all of this with us. And yeah, as always, I will be uploading the recording tomorrow morning my time, and I will also attach the presentation to the Notion.
Cool.
All right, so we are back tomorrow, same time, with a session on giving your agent a wallet with Privy. So it would be hopefully a very hands-on session as well to understand how to use the Privy SDK and library and actually give your agent a wallet. That's it. So let me stop the recording and ciao, everybody. Have a good day.
Thank you, everybody.
Thank you, everybody, for joining us. Ciao.